Okay, we're going to finish up with application here. In order to do the application, first you need to know some terminology: angle of elevation, angle of depression. Okay, so excuse my poor artistic skills, but I'm sure you'll do a better job drawing yours. So let's say we have a happy little person down here, and they see something up in the air. I don't know, it's a bird, it's a plane, it's a flying finger, or whatever you think that is. Okay? Now, normally when somebody is walking or looking, they look straight out. Okay? So when you look straight out, your line of sight, this is called the line of sight, your line of sight runs parallel to the ground. This is a horizontal line. It's an imaginary horizontal line. And then, if you spotted something up in the air, you would look up at that object. Well, there's an angle that's formed from your line of sight to what you're looking up to. So when you look straight up, there's an angle that's formed in between this. This is called the angle of elevation. Okay? That's the angle of elevation. Well, the person in this flying finger, well, they have their own line of sight. Okay? And their line of sight is parallel to the ground as well. Okay? Well, that person looks down at you. Well, the angle that's formed from their line of sight to what they look down at is called the angle of depression. Angle of depression. Now, from geometry, you should know if you had two lines that were parallel crossed by a third line, these angles here are called alternate interior angles. That's what we call the Z pattern in geometry. And what do we know about those two angles? Those two angles were always congruent. So these angles are equal. That means the angle of depression and angle of elevation, these here are equal. Okay? And that's really important. What I would do, anytime they give you an angle of depression, I would set it up as an angle of elevation going the opposite way. Okay? So let's go ahead and let's do an example, and we will be done. Okay? So let me scroll this up. This. So we've got the string of a kite is held at a 52-degree angle of elevation. Okay, so we've got the ground, we've got a person, they are flying a kite. So here's a kite. Okay. And it says that it's being held at a 52-degree angle of elevation. Well, in this case, the angle of elevation is not formed from the eyes, it's actually formed from the hand where the string is connected, because the string is acting as our diagonal line here to what we're going up to. Okay? So how much string would you need to let out? So we want to know how far is it from here to here, how much string, we'll call that X, to get the kite 400 feet off the ground. So from here straight down to the ground would be 400 feet. Okay? Now, it says the string is being held 5 feet off the ground. So the distance from here to here is 5 feet. So this imaginary line is 5 feet off the ground. So that means from here to here is 5 feet, which would make from here to here, this distance there, 395. So on this triangle, this would be a 9-degree angle, this is 9 degrees because they're going straight up. So this would be 395. So we've got this triangle here where we're looking for the hypotenuse. We know this side is 395, and we know this angle, they told us, was 52 degrees. So now we can use our trig ratios. We've got so, con, toe. So we're going to use the 395, the 52, and the x. Well, Everything's in reference to an angle, so where's the 395 compared to the angle? That's opposite. So it's either going to be sine or tangent. And where is x? X is the hypotenuse. So that's going to make this a tangent. We have, oops, no it's not. That was funny, wasn't it? We have opposite and hypotenuse, so that is sine. Opposite and hypotenuse. So we have the sine of our angle, which is 52, equals opposite, which is 395, divided by your string, which is your hypotenuse, which is x. So now, because our variable's in the denominator, we're going to multiply or divide. What is that? Oh, we're going to divide. So x is equal to 395 divided by sine of 52. Okay? So we pop that in the calculator. Clear. 395 divided by sine of 52, and we get 501. Is that right? So x is approximately 501.3 feet. Okay. And does that make sense? Well, we know it has to be more than 395, so that appears to be correct. Okay.